Question number 70. Three identical resistors R1, R2 and R3, each of resistors 2 ohm, are connected to a cell of negligible internal resistance. So there are R1, R2, R3, these have no internal resistance. Then this voltage source V is it given? V is not given. Okay. When switch S is open, when this is open, no current will pass through it. So this current will be 0 here. Okay. The power dissipated by R1 is 18 watt. Power dissipated here is 18 watt. Remember, this is power here and not resistance over. Okay. So what is the power dissipated by R1 when S is closed? The question is really very simple. It asks, when it is open, power is 18 watt. When it is closed, what will happen to the power? That's the question over here. Now how do we determine? See, now each of them is 2 here, 2 here, 2 here. So therefore, when this is open, this we need not consider. Because no current is coming. It is not considered here. So therefore, the effective resistance is 2 and 2 here. But before that, see, if I is the current passing through it, okay, then what can happen? I squared multiplied by R1 would be equal to 18, right? Power dissipated is I squared into R1. What is R1? 2 watts. So this I squared into 2 is equal to 18. I squared equal to 9. I is equal to 3 amperes. This is what we get. Okay. Next, what we have? We want to find this V. Why do we want to find the V? Because when this is closed, we want to find the wattage over here. So towards it, I need to find the current. So we need this. Well, let us do one thing. Let us find out the value of V here. So now what happens when this resistance is removed? We'll have one single resistance here. See, because R1 plus R2 will be the effective over here, which would be 4, and this is V here, and this is your current, which is 3 ampere, and this is how it is connected. So what will be the voltage here? 3 into 4 Ohm's law, right? 12 volt. 12 volt is the voltage supplied over here. 12 volt is the voltage supply. Will this voltage supply differ when I put the switch on? It will not differ, right? It will remain the same. So we have found out one more quantity over here. Now what's the next thing that we need to do? We have got this 12 volt over here. Now when this switch is closed like this, now what will happen? So effective resistance here decreases, right? What will be the effective resistance now? This is 2, this is 2. Parallel would be 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 would be 1 by parallel, which would be equal to 1. In other words, R parallel is equal to 1 over here. So I got this as 1. And this is once again in series with this. 1 plus 2 becomes 3. So R total becomes 1 plus 2, which is equal to 3 ohms over here. Okay. Now what is the current in that case? Current I total now after closing would be equal to 12 divided by 3, which is equal to 4 ampere. What happened? The current increased. Earlier it was 3 ampere. Now it has become 4 ampere. Why? Because the resistance is reduced over here. So as a result of it, the effective resistance reduced, and hence the total resistance reduced, and hence the current increased. Okay. Now what next? Again the same thing. What is the same thing? So a current of 4 ampere is coming here. Current of 4 ampere is coming here. It sees there are two rods, two resistance over here. They are equal, which means how much will flow here, how much will flow here? 2 ampere will flow here, 2 ampere will flow here, right? So therefore, I need to once again do the same calculation, what I did here. What was it? I squared multiplied by R, right? What is I squared now? 4 ampere multiplied by R. What is R here? 2 over here. So 4 into 2 becomes 8 watt. So the answer is 8. Okay.